Okay, hello kids. This is Mr. Mario again here with one of our Tinkercad tutorials. So, today we will learn about connectors, especially the axle connector. So, I am going to create 3D design. Okay. Now, what we will create? Here in settings, 220 per 220. Okay. Choose the settings of your preference. I'm okay with 220 per 220. Now, I am bringing a cylinder. Any cylinder is okay here. No big mystery. I will modify the sides and I will change the color. Let's say red. Okay. Now, I will bring from basic shapes. Here we have basic shape from the library, creatures and characters. I'm going to more shapes. You can search in animals. I am bringing this Robert duck. Okay, I am rotating it 90 degrees. Now, this duck is too big. So probably you remember that if you use the shift key, if you keep it pressed while moving one of the handles, you can scale your object. You can make it bigger or smaller, all the dimensions at the same time. Sorry, that was from another. Now, I press shift, I reduce the size. Okay. Now I duplicate. Remember, you can duplicate using this, duplicate and repeat. Or you can also use Command D if you are in a Mac. Or you can also use Control D if you are in a Windows. Okay. So, I duplicate the duck. I bring it here. And I will rotate it 90 degrees. Sorry, 180 degrees. Perfect. I align the dogs. I select both of them. And I use the align option. I align to this middle. And I group them. Control G or Command G, group. Good. Now they are one single piece. Now I am bringing from basic shapes a box. So let's modify the dimensions. Okay. Let's change the color. Let's change it for a green color. Okay. I select the ducks and the box. I align to the middle, here this middle and this middle, and I group. Okay. So far, we have two shapes. Number one, the cylinder. Good. And number two, these ducks joined together by a bar, by a box. Okay. Now I will place this, the dogs with the bar, I will place them over the cylinder. You can use C, the letter C, to activate the cruise. So look, if you click the object and you click C, you can move the object, clicking here in this handle, and place it where you think is better, here, over this surface. Good? Okay, I will move it a bit up. So I am moving it up so you can see what I am doing. But if you want to put it closer to the cylinder, your choice. I will align, so I select both of them, align, align to this middle, align to this middle. Okay. But remember, we have two shapes. Don't group these shapes. No, don't group them. Shape number one, shape number two. Okay. Now we are going to the SimLab environment. Here you can see the SimLab environment, the apple falling. I click it. Okay. Perfect. If I click start the simulation, nothing special happens. Now we will learn about connectors. What is a connector? Basically is like a component that allows us to create movement, specific movements in our creations. We have different connectors. We have, sorry, the axle connector that allows us to spin, to create a spin, rotations, basically that, or rolls. If you want, you can use it this to create wheels of a car or to create a gears mechanisms. We have the slide connector, the slider connector. We'll talk about that another time. We have the pivot connector. Again, we'll talk about that sometime. And we have the tracer. We will talk about the tracer in another time. I am bringing the axle connector and I bring it here on top of the cylinder. If it's hard for you to place it on top of the cylinder, then just hide the dogs, yes, and bring it to. So it's up to you. You can place it here in the center, and then you can make the dogs appear, okay? Or you can just simply bring it here on top of the cylinder, your choice. But it needs to be on top of the cylinder. Okay. So now, as you can see here in the connector, we have like some kind of little circles. This gray circle with the gray circle, we will select which component will be the one spinning and which component will be the base one, like the component where the other component is spinning around. So I click and drag this gray one. As you can see, when I choose the spinning component, the dynamic component, it it becomes blue, but it's not blue of color. It's just indicating that this is the spinning component, the mobile component. So I choose the ducks. Good. If you check the orange is the base component, is where you want the object to spin around. Okay. So the base object was colored with orange, and the spinning object, the blue one, with blue. Okay. Let's test. Let's start simulation. Nothing happens. But if you shoot an object, oh, it's spinning. Let's reset. So start simulation. As you can see, there is some spin here. It's spinning. Okay, reset. Now, if you remember our previous lessons, if you want this component to stay in place without moving this shape, you select it and you make it static. This one here, you click here and you make it static. Now the cylinder is static. And the model component must be dynamic. So let's try again. Let's shoot something. Oh, perfect, it's working. Okay. Now, a axle component has an advantage, and is that you can transform it into a motor. Let's remember, a motor is a device or component that transforms electricity into motion, circular rotational motion. Or if you prefer, it transforms electrical energy into mechanical energy, usually as a rotation. So, in a motor, you have two kind of settings. Number one, torque. Number two, motor speed. What is the difference? A motor, the speed is how fast our object spins, and torque is how powerful that spin is. They are different. If you compare a motorcycle to a tractor, you know that the tractor is slower, but is more powerful and it can carry heavy things. A motorcycle is faster, but it's not as powerful, so it only can carry two people with some things. So as you can see, sometimes you need to sacrifice power so you can have speed and vice versa. Okay, now all motors need some little torque at least, and here I will add a little speed, 96. So now look, that is spinning by itself. If I increase the speed, as you can see, it's showing me the direction of the rotation and how fast it's going. If I increase the speed, it will go super fast. Good. Now, as you can see, motor torque go from 0 to 170. Okay. And motor speed. Okay, I will reduce the torque a bit. And motor speed, you find that you have positive until 400 revolutions per minute, and you have negative. What is the difference between positive and negative? The direction. So let's test. Minus 39 rotations per minute. You can see that it's going in this direction. And if you change it to positive 57, it will go in a different direction. Okay. Now I will teach you how to share this video, because remember that for the homework you need to submit a video. So how can we do? You use the share option. With share you can create a video, but there is one condition. If you just click share, it won't show you any option to create a video. So let's close it. You need to start the simulation, because it cannot record a video if you haven't created any motion with your model. So as you can see, it's moving. Good. Yes. If you want, you can pause the video. Okay. Now that the simulation is working, yes, you click again share. And as you can see, now I have the option to create the video here. Here, create video. Okay. So here is the simulation. Very good. Create video. Let's make, okay. You can here choose the dimensions of your video. You can also choose how big you want your video to be. So let's do it 640. Create video. Wait a few seconds until it creates the video. Okay, a few seconds. We almost finished. Okay, now here as you can see, create the video to download. Remember, download it to your downloads folder. Okay, give it a name that you understand what is this video about. So you can call it Axle Connector Sim Lab Mario. Okay, save and go. Here, now you have the video. Only a few seconds, 10 seconds, but it's enough to see the play in action. Okay, guys, thank you very much. This video was very short, so I hope this was very instructional. So please don't forget to check that it's working. See you guys. See you in our next lesson.